distillation unit is usually used for separation of mixtures at atmospheric pressure. Here are some special features of hatchback distillation unit. First, it uses cartridge heaters to direct heat input into the evaporator. Second, it has silver-coated and vacuum-jacketed column to minimize heat loss. Third, it allows vapor and liquid sampling on the bottom and the top to determine the separation behavior of the particular mixture. Next, I'll explain to you the method of separation of a pipe distillation unit. First, the vapor mixture rises from the evaporator, passes over the ring columns through packings, and is fully condensed at the condenser. Then, the condensate runs down the column to the vapor through packings back into the evaporator. In ideal case, the rising vapor will attempt to achieve equilibrium with the liquid, but in actual columns, complete exchange does not always take place. Furthermore, the efficiency of a distillation unit is categorized by height of equivalent theoretical plates (HETP), which is height of column divided by number of theoretical plates required to achieve the same separation as a packed column. There are three objectives in carrying out this experiment. First, to determine the HETP at constant reflux. Second, to determine the effect of vapor and liquid sampling on HETP at total reflux. Third, to study the change in top and bottom composition as well as HETP over time at constant reflux.
For this experiment, we need to prepare refractive index versus composition plot. To do this, prepare a set of mixtures containing ethanol and water within a specified range of composition between pure water and pure ethanol. After that, we need to obtain their refractive index reading using a refractometer. Lastly, from the data obtained, plot a refractive index versus composition graph. This will serve as the calibration curve for further experiments. Procedure for experiment 1, batch distillation at total reflux. First, perform the general startup procedure as shown. Second, once the distillation unit has reached stable condition, record the top and bottom temperature from the control panel, where T1 is for the temperature of bottom product and T2 is for the top product. Third, collect the samples for bottom and top product. This is bottom product and this is top product. After that, measure the refractive index of the both sample and their composition. Finally, repeat the step for different heater power setting. For experiment 2, batch distillation at constant reflux. First, do the same procedure as experiment 1, however, turn the heater power setting to 70% throughout the experiment. After collecting and measuring refractive index of each sample, set the reflux divider to give a reflux ratio of 1 by turning it to auto. After 10 minutes, collect again the sample of both products and measure their refractive index and also compositions. After that, measure the distillate flow rate as follows. Repeat step 3 and 4 for every 10 minutes for at least 1 hour. Finally, measure the volume of distillate collected and also the volume of liquid left in the reboiler.
Now, I will continue our presentation today with the result and discussion of this experiment. The first part of this experiment is the preparation of calibration curve of ethanol water mixture. Calibration curve were used to determine the mole fraction of ethanol in the main experiment. Calibration curve can be obtained by plotting refractive index versus the mole fraction of ethanol. This graph demonstrates how to measure the mole fraction of ethanol by using the calibration curve. For example, when we know the refractive index for the ethanol, we can use the calibration curve and then see the value of the mole fraction of the ethanol. Now, I will explain about the result of experiment A. Experiment A is conducted at total reflow condition. Total reflow condition means that there is no distillate exist from the distillation column, or in another word, distillate is completely recycled back into the distillation column. In this experiment, we vary the heater power. After collecting the composition of the top and the bottom product, the mole fraction of the composition were measured by using the calibration curve. And then, after getting the mole fraction of the ethanol, we use Taylor method to determine the number of stages. The effectiveness of the distillation then were measured by using HETP. HETP is calculated by dividing the effective height of the column with the number of theoretical stages. In order to measure the effect of power to the distillation, we plot the graph of HETP versus the heater power. From this graph, it can be concluded that HETP will be increased when the heater power is increased. So this means that as the heater power increases, the number of theoretical stages will be decreased. It can be concluded that the effectiveness of the distillation will be increased as the heater power will be increased. That's all.
In this experiment too, the distillation column is operated at the same reflow ratio, which is fine. This means that the distillate exit and re-enter the distillation column is supposed to be the same. Based on our result, we can see from this figure, it shows that the mole fraction of ethanol is increasing by the time passes, while the mole fraction of ethanol at the bottom shows the opposing trend, which is decreasing. This means that the purity of ethanol in this distillation column is increased as the time increases. And this is strongly justified by the graph of ethanol in the evaporator, which show the decreasing trend. While the HETP result, it shows that the HETP is remaining constant as the time passes, except for the last 10 minute interval. This shows that the number of critical bits is increasing within that interval. And according to the McCabe-Tal method, it seems that when the concentration of distillate increase, it will increase the number of critical bits, as well as decreasing the HETP as the time passes. To calculate the percentage error in this experiment, it can be calculated from the equation where the experimental value we minus with the critical value and divide by the critical value, and then we time with 100, so that we will get the percentage error. The experimental value we can obtain from the experiment, which is from the initial composition of the boiler, and the value is 0.343, while the theoretical value can be obtained from this equation, which is F is equal to dXT plus dXP, and we need to find the XF. And final result, we obtain that the percentage error is equal to 61 from 0.72, which is the largest value of percentage error.
In this experiment, there are three types of error that has been found. The first one is the parallax error. Parallax error occurs due to human factors. This might become due to the lining of the eyes that are not correctly positioning when taking the readings. This will reduce the accuracy of the data. To avoid this, students must make sure when taking the data, they must in full attention and focus, and the eye must be perpendicular to the scale of the reading. The next one is the human error. Human errors occurs when students take the samples and leave the samples without covering it with the caps. This will make the ethanol to be vaporized into the air. This will reduce the accuracy of the data. To avoid this, students must make sure that each time that they take the samples, they must close the caps well. The last one is the systematic error. Systematic errors comes due to the failure of the equipment. In this experiment, the refractometer that we use is failed to recalibrate. This will affect the accuracy of the data. To avoid this, technician must make sure that they do the regular maintenance with the equipment before starting the experiment. For conclusion, in experiment 1, it can be concluded that the heater power affects the number of stage and HEDP, that is stand for height of equivalent theoretical plates. For experiment 2, it can be concluded that the number of stage and HEDP increase over time. However, this effect cannot be seen for short period of time. The amount of ethanol in distillate increase over time, while the amount of the ethanol in bottom parts is decreasing. Thus, we can conclude that the distillation is more effective when running at longer period of time. That's all from our group. Thanks for watching this video.